everyone, myself Shivangi Desai, your instructor for the video series of data mining and business intelligence. Today's our topic is architecture of business intelligence and data warehouse. So let's get started. In business intelligence, there are mainly three components, that is data sources, data warehouses and data marts, and business intelligence tools. So let's understand what is data sources. For the business intelligence process and methodology to be integrated, it is important to have the right understanding of the data sources. Pulling raw data from different sources, internal and external, is vital to the diverse analysis options. Companies tend to store huge amounts of operational data. Business intelligence needs to navigate between the data sources. In most companies, mainframe legacy systems create a foundation for the data centers because they can deal with large volumes of data. However, such data is usually difficult to procure since many legacy apps are often obsolete or proprietary. This component of business intelligence involves various forms of stored data. It's about taking the raw data and using software applications to create meaningful data sources that each division can use to positively impact business. Business intelligence analysts using this strategy may create data tools that allow data to be put into a large cache of spreadsheets, pie charts, tables, or graphs that can be used for a variety of business purposes. For example, data can be used to create presentations that help to structure attainable team goals. Looking at the strategic aspects of data sources can also help organizations to make fact-driven decisions that take into account a more holistic view of the needs of the company. Next component is data warehouses and data marts. The data warehouses is the significant component of business intelligence. It is subject-oriented and integrated. The data warehouse supports the physical propagation of data by handling the number of enterprise records for integration, cleaning, aggregation, and querying tasks. It can also contain the operational data, which can be defined as an updatable set of integrated data used for enterprise-wide tactical decision making of a particular subject area. It contains live data, not snapshot, and retains minimal history. Data sources can be operational databases, historical data, and external data. For example, from market research companies or from the internet, or information from the already existing data warehouse environment. The data sources can be relational databases or any other data structure that supports the line of business applications. They also can reside on many different platforms and can contain structured information such as tables or spreadsheets, or unstructured information such as plain text files or pictures and other multimedia information. A data mart is a collection of subject areas organized for decision support based on the needs of a given department. Finance has their data mart, marketing has their own data mart, and the data mart for marketing only faintly resembles anyone else's data mart. Perhaps most importantly, the individual departments own the hardware, software, data, and programs that constitute the data mart. Each department has its own interpretation of what a data mart should look like, and each department's data mart is specific to its own needs. Similar to data warehouses, data mart contains operational data that helps business experts to use strategy based on analysis of past trends and experiences. The key difference is that the creation of a data mart is predicated on a specific predefined need for a certain grouping and configuration of selected data. This can be multiple data marts inside an enterprise. A data mart can support a particular business function, business process, or business units. And the last component of business intelligence architecture is business intelligence tools. Under the umbrella term of business intelligence, there are many tools that are used to analyze the various components of business intelligence and construct them into actual problem-solving actions. Today's wide use of the internet and the great entrepreneur spirit of our free market economy have fostered new market and startups as well as consulting firms and other business ventures that have helped build many business intelligence tools. These specific business tools can help leaders to look at components of their business in more depth and detail. The most common tools in use today include business and data analytics, predictive analytics, cloud technology, mobile business intelligence, big data consultation, and visual analytics. Now let's understand the architecture of data warehouse. Figure depicts the typical architecture of data warehouse, which contains different components like operational sources, load manager, warehouse manager, query manager, detail information, summary information, archive media, metadata, and access tools. Now let's understand each of these components in detail. First, operational sources. The data is extracted from the operational databases or the external information providers. The sources of data for the data warehouse are supplied from the mainframe systems in the traditional network and hierarchical format. Data can also come from relational DBMS like Oracle, Informix, etc. In addition to this internal data, operational data also includes external data obtained from commercial databases and databases associated with supplier and customers. Next is load manager. The load manager performs all the operations associated with extraction and loading data into the data warehouse. These operations include simple transformation of data to prepare the data for entry into the warehouse. The size and complexity of this component will vary between data warehouses and may be constructed using a combination of vendor data loading tools and custom built programs. Next is warehouse manager. The warehouse manager performs all the operations associated with the management of data in the data warehouse. This component is built using vendor data management tools and custom built programs. The operations performed by warehouse manager include analysis of data to ensure consistency, transformation and merging the source data from temporary storage into data warehouse tables, create indexes and views on the base table, generation of aggregation, backing up and archiving of data. In certain situations, the warehouse manager also generates query profiles to determine which indexes and aggregations are appropriate. Next is query manager. Query manager performs all operations associated with management of user queries. Query manager is responsible for directing the queries to the suitable tables. Query manager is also responsible for scheduling the execution of the queries posed by the user. This component is usually constructed using vendor and user access tools, data warehousing monitoring tools, database facilities, and custom built programs. Next component is detailed information. This area of the warehouse stores all the detailed data in the database schema. Detailed information is not kept online, rather it is aggregated to the next level of detail. The detailed data is added regularly to the warehouse to supplement the aggregated data. Next component is summary information. It is a part of data warehouse that stores predefined aggregations generated by the data warehouse. It must be treated as transient as it will be subject to change on an ongoing basis in order to respond to the changing query profiles. The main goal of the summary information is to speed up the query performance. As the new data is loaded into the warehouse, the summarized data is updated continuously. Next component is archive media. The detailed and summarized data are stored for the purpose of archiving and backup. Data is transferred to storage archives such as magnetic tapes or optical disks. Next component is metadata. The data warehouse also stores all the metadata definition used by all processes in the warehouse. It is used by a variety of purpose including extraction and loading process, the warehouse management process, and as a part of query management process. The last component is access tools. The main purpose of a data warehouse is to provide information to the business manager for strategic decision making. These users interact with the warehouse using end user access tools. Now let's understand three-tier architecture of data warehouse. The figure depicts three-tier architecture of data warehouse, which contains three different layers, that is bottom level, middle level and top level. Starting with the bottom tier, it is a warehouse database server that is almost always a relational database system. Backend tools and utilities are used to feed data into the bottom tier from operational databases or other external sources. These tools and utilities perform data extraction, cleaning and transformation as well as load and refresh function to update the data warehouse. The data are extracted using application program interface, which is also known as gateway. A gateway is supported by the underlying DBMS and allow client programs to generate SQL code to be executed at a server. Some of the examples of gateways include ODBC, that is Open Database Connection, and OLEDP, that is Open Linking and Embedding for Database by Microsoft, whereas some other are JDBC, that is Java Database Connection. This tier also contains a metadata repository which stores information about the data warehouse and its contents. Next is middle tier. The middle tier is an OLAP, which is Online Analytical Processing Server, that is typically implemented using either a relational OLAP or a multidimensional OLAP. A ROLAP model, that is an extended relational DBMS that maps operations on multidimensional data to standard relational operations, whereas a MOLAP model, that is a special purpose server that directly implements multidimensional data and operations. And last is top tier. The top tier is a front-end client layer which contains query and reporting tools, analysis tools and data mining tools. So that's it about this lecture. Thank you.